Hey guys, Mr. Kyle at Myers Mathematics, and let's just jump right into it. So the ambiguous case, I'm assuming you've already heard of it. If you've clicked on this video, you kind of already know a little bit about it. It's kind of this thing where there's like two triangles possible, and maybe you've already even read the textbook a little bit, or your teacher gave you some notes on it, and it has to do with some formulas that you use to figure out whether you have a triangle or not. But I'm going to show you kind of an animation, and there's other animations out there too. I'll put a link in the description maybe of where to find these. But here's what you can do in order to visualize this and what's going on here. And then I'll kind of maybe give you some alternatives to using the formulas that they give you in the textbook or maybe that your teacher gave you. Okay. So we have a line, and we need this line to build our triangle off of. And actually there's kind of this rule when you're making triangles that you can make this line and assume that one of the sides of the triangle is on this line somewhere. Okay, so it's kind of a thing where you can just assume that, and it's just sort of a math thing that happens. Okay, so I'm not going to get too much into that, but we need, in the ambiguous case, two sides and an angle. So side, side, angle. All right, and of course, if you haven't figured out why it's side, side, angle, it's because if you spell it the other way, it makes a cuss word, spells a bad word. So of course, textbooks are not going to spell it that way for obvious reasons. So it's side, side, angle. But that's how you can remember it if you want. It's the if they give you the three letters that spell a bad word backwards, that's the one we're talking about here. That's what gives you the ambiguous case. Okay, so here's what happens. If we have a line, let's give a line segment, right? We can have a line segment like this, acute, right, or obtuse, right? So let's look at our right angle first. If we have a right angle, right, so it's exactly 90 degrees. There's only one way. So let's say I'm given a side. So let's say this is 4. So here's my example. I have a 4 here. And then let's say I have another side of 5. And then my angle is 90 degrees. Well, there's only going to be one way to do this, because there's only going to be one way to connect this side 4 to the ground. And it's going to be kind of like this. Okay, it didn't quite connect, but you get my point here. So this is going to be my 5. There's only one way to do that. If I were to try to connect it this way, it'd kind of produce the same result. And it would just be the mirror image, so it wouldn't really matter. And besides, it wouldn't be this 90-degree angle that we're talking about. So even though it does make a mirror image, it doesn't really matter. Later on, it does matter that angle, that particular angle that we already marked, is the one that's represented. Semantics, right? So if we have this 5, there's only one way to get there. There's only one way, because if I go and let's say I do this. Let's say I do this. I got this blue marker. If I go this way with it, that's going to be less than 5. That's going to be like 4 point something. And if I go this way with it, well, this might be like 8 or something like that, right? So if I go to the left or to the right and connect it to the line so that I have that 90-degree angle, it's not going to work. It's just not going to work. There's only one way to get that 5 number, so there's only one triangle here. There's only one triangle. So in this case, there's one triangle. Triangle. Now, if I had a 4 and let's say a number between 0 and 4, and then an angle of 90, then I wouldn't have a triangle at all, because you can see here that if I had an angle of, or a side of, like, let's say 3, then it wouldn't even connect, right? Here's a side of 3. It would look something like this. It wouldn't even connect. So it needs to be a certain length, and you would find that out, of course. You wouldn't have to draw this out every time. So I'm just kind of giving you a visual. If you use law of sines, to find out what the angle would be, you'd get an error message. So that's all you'd have to do is just use law of sines. You get an error message. Hey, that means I don't have a triangle. Okay, so I'm just kind of showing you visually what that would look like. The reason why sometimes you don't have a triangle at all in this ambiguous case scenario, side-side angle. So that's if you have a 90-degree angle. There's only one possible triangle if you have a triangle at all. Right? Now let's look at an obtuse angle. It's going to be pretty much the same thing, so I'll go through it pretty quickly. All right, so we have a side here, and we can assume that the triangle is going to have a side on this line somewhere. Okay, and let's do another side of 4, just for no particular reason. So let's give an obtuse angle this time. So let's say it goes out to here. And let's say that's a side of 4. So now we have this angle, which is maybe 120 degrees. So we have side, and actually over here, this side of 4 should really be the other one, but it's all good. So let's say we have a certain side. We don't know. But then we know this 4 side and we know this 120 angle. So you could say, well, couldn't I just drop down a side over here? Like let's say just do something like this, right? Or just go like that. Well, no, because then I'd have, a triangle that's in here, right? This would be my triangle. And then this angle wouldn't exist anymore. So no, I can't do that. I have to connect. Get rid of all that scratch right there. I have to connect so that it goes from the tip of this out to here somewhere on the right-hand side in order for me to close in that 120-degree angle so that it's actual angle. It's an actual interior angle of the triangle, which is what they tell you. They tell you, hey, I have this interior angle of the triangle that's 120 degrees. That's your given information. So it has to be on the right-hand side for this to work. And again, we run into this problem. So this looks like maybe 7, right? So let's say 7. So there's only one way to do this. Okay? There's only one way, because if I had, let's say, anything greater than 7. So if I was out here, greater than 7, so out here somewhere, that'd be more than 7. And then if I do it again, right? So if I on the other side, over here, it'd be less than 7. And then, of course, if you add a 4, then you run into problems again because you don't get things that connect. So it just doesn't work out. There's no ambiguous case. So one of the first rules of the ambiguous case, and I'll go ahead and create my scenario for the acute angle before I start writing out what the rules are in English, right? Not in the fancy text of your math book. But one of the rules is that it has to be acute, right? Assuming we have a side and an angle to start with. So here's the rules. And I'll insert it as a text box so it's really easy to see, because sometimes my handwriting is not always the best. Oh, no, that's not what I want. Here, let's just do this. So the rules. We have, first of all, it has to be side-side angle, right? It has to be side, angle. Okay, I'll zoom in on this a little bit here. It has to be side angle. And then number 2, it has to be acute. The angle given must be acute. Because if it's not, then you can tell you're not going to have 2 triangles. And the ambiguous case usually means that there's 2 triangles. It's ambiguous, meaning it's unclear how many triangles you have. That's what the whole thing means, really. So we've come across 2 things. 1, all of this only works if you have side angle. 2, the angle given has to be acute. So those are your 2 check marks. Right? If it's not side angle, or if it's not an acute angle, it's either going to be a triangle or it's not going to be a triangle. End of story. Okay. So let's go back to my draw here. Let's say we have, what's it do? Another side of 4. So here's my side of 4. Actually, this is much longer looking 4 than my other ones, but nonetheless, we can say, actually, you know what? Let's do this. Let's say it's 5. We'll make it a 5 this time. And this angle looks like maybe 30 degrees. We'll just say it's 30 degrees. Okay? Doesn't really matter what you call it. 30 degrees is acute, so that's fine. So we have a side angle scenario. And the other side that I haven't named yet is the side that's going to connect from this point down to the ground, right, down to the ground, somewhere to make the triangle complete. So we don't know what that is yet. We haven't created that yet, but it's something, and then another side, so 5, and then an angle of 30 degrees. Okay, so the first thing is you're going to be given, if this is just a practice problem that you're first given, they're going to give you that side length. All right, so let's say they gave you a side of, I don't know, 3. Now, you can figure out whether that 3 is even going to give you a triangle or not. Okay, so there's going to be some rules here, and that number is important. The number that's across from the angle. So this would maybe be called side A, and this would be called angle A, and this could be side B or side C. It doesn't matter if they call it B or C, but the angle has to be across from the side. So they'll be the same letter, but one of them will be uppercase, one of them will be lowercase. Okay. Now let's just say they give you a 3, and I'll put it in green because I might not keep that number. I might change it. But let's just say they give you a 3. Okay. We need to figure out if we have 0, 1, or 2 triangles, because it's possible, right now it's possible that we have 0, 1, or 2. Okay, so we have to figure out, okay, how do we know? There's 3 different options there, right? That seems like a lot. And there's some formulas that they give you, but here's what you do, okay? There's going to be exactly 1 triangle if I go straight down. All right, so I'm going to use a different color for this. If I go straight down, I have exactly 1 triangle because there's only one way to go straight down. If I were to go to the left or to the right of that and hit the ground, it wouldn't be straight down, and it'd give me a number that's bigger than that. So this number, this is your magical number, whatever this is, x. That's your magical number. So what I would do is I would find out what that is. Okay, and again, this is where these formulas come from, is this idea here. But you could do this really easily. Sine 30 equals x over 5. And it's always going to be the sine, right? So you don't have to do a trig ratio per se every time. It's just going to be the side next to the angle times the sine of the angle. Okay, that's all you do. You take the number that's next to the angle, multiply it by the sine of the angle given. Okay, that's what you do every single time. So whatever this number is, and you can find out what this is pretty easily. You could type it into a calculator if you're not sure what sine 30 is, but sine 30 is 1/2. So half of 5 would be 2.5, or 5 halves, or whatever you want to call it. So it's 2.5. Okay, so 2.5, this is a very magical number for you. Okay, and here's why. If you're given a side that's less than 2.5, okay, like let's say you were given a 2 instead. If you're given a 2, you don't have a triangle. Okay, look, there's only one way to go straight down. If I were to go out, I'd have to go further, right? Here's all the ways I can do 2. Right? It's just not going to reach the ground, and it's not going to make a triangle. So I have no triangle. There's no way to do that. Right? So there's my side of 2. It just doesn't work. So there's no triangle. If it was exactly 2.5, well, then I'd have exactly 1 triangle. There's only one way to do that. There's only one way to go straight down. Now, if I have a number greater than 2, then, I have 2 triangles. Okay, up to a certain point. So let's draw this out here, and I'll use an official line this time instead of just kind of sketching one. But let's say we go with that 3 number again. So let's do that 3 number again. And there's 2 ways to do that. If I have a 2.5, I can go down to here, or I could go down, starting from the same place, and go down over here, right? And of course, I'm kind of sketching it out so it's not exactly the same. We're just assuming that it's exactly the same length here. But this could be my 3, and there's also a 3. So there's 2 triangles there, right? There's 2. There's your ambiguous case. Okay, so you can find it out by using a simple trig ratio, and then from that trig ratio, you have your 3 scenarios up to a certain point. Okay, so in this example, here's what's going on. Here's what's going on. Okay, if you have any number from 0, and I'll write this over here. If you have any number from 0 to 2.5, right? So we found that value out by doing the side given that's not across from the angle multiplied by the sine of the angle. Okay, so any of those values, not including 0, of course, and not including 2.5, you don't have a triangle. You have 0 triangles, 0 triangles. Okay. If you have exactly 2.5, then you have exactly 1 triangle. And then if you have more than 2.5, up to a certain point, then you're going to have 2 triangles. Well, you're probably like, up to a certain point? What do you mean? Couldn't you just keep going? Well, you can until you reach 5. Until you reach 5, until you reach this thing. Because once you reach 5, it's all over. That's it. Because now, let's use a different color. Let's use this pen. If I have exactly 5, well, I can't go back where I came from, right? Because if I did that, see that? That's not a triangle. That's just a line overlapping itself, you know, a line segment, technically. And it's just overlapping itself. That's not even a triangle, right? And then the other place where 5 would exist would be out here somewhere, right? Right about there, maybe, right? So here's the other place where 5 exists, is way out here, right? And so there's only one way to get to 5, because if I went back, you know, to the left, well, then I wouldn't have a triangle at all. And then, of course, if you had a number bigger than 5, so let's look at that real quick. If you had a number bigger than 5, let's use a different pen, then you'd have the same problem. Because if I go out here, right, I can touch the ground, and I can make a triangle, but that triangle now isn't guaranteed to have a 30-degree angle. At least not the 30-degree angle that I started with, because now this is a totally different triangle out here. This is a whole different triangle, right? And at some point I'll reach 30 degrees eventually, but not down here on the ground. It would be an angle, you know, over here somewhere. But I could keep going this direction, right, on this line. So maybe like a 6 or more, right? So you can keep going. But once you reach that 5 number, right, so there's the number I didn't put in there. Once you reach that 5 number, you're done. And if you have anything more than that, then you have exactly 1 triangle again. Okay? So there's your magic number. That 2.5 number, there's the magic. Okay, so let's put this into some rules that are easy to remember. What you need to do, the angle given must be acute. Okay? So here's kind of a step, not necessarily a rule, but a step. So you take the number, right, not across from the angle. This is all stuff I said earlier. You take the number that's not across from the angle and multiply by the sine, right, which is actually spelled S-I-N-E, the sine of the angle. Okay, and that number, right, so this is kind of rule 3 is kind of a step and not a rule. But once you get that number, then here's the rule. If the number across from the angle is less than in step 3, no triangle. Okay, that's kind of already what I typed out over there, but I'm kind of writing it in a more written form here. And I'm going to say basically the same thing, but I'm just going to tweak it a little bit here. So if the number across from the angle is equal to, and not 3, right? This is step 3. Equal is less than what the number that you get in step 3 is equal to the number you get in step 3, then you have exactly one triangle, right? So one triangle is possible. Okay. So for instance, in our case, that number in step 3 that we got was that 2.5 number. Okay. So that's what I'm referring to here. So if the number across from the angle is less than what you get in step 3, in rule 3, then you have no triangle. If it's exactly equal, you have one triangle. If it's more, so if the number across from the angle is less than the side across, but less than, if the number across from the angle is less than the side next to, there we go, right, next to the angle. Okay, if this number across from the angle is less than the side next to the angle, but it's bigger than the side across. Bigger than, there we go. Okay, so if the number across from the angle is less than the side that's next to the angle, right? So in this case, it was the 5 number. Okay, so our number 3 in this case, this green 3, if that number, right? So rule 6, if the number across from the angle is less than that number, but bigger than the other one, then you have exactly one triangle. Or sorry, you have exactly 2 triangles. I'm confusing myself. 2 triangles. And then of course, if your number is bigger, then you're going to have 2. So I'll just go ahead and finish this out. Sorry, it's a little bit confusing. I think my written example was a little bit more, made a little bit more sense here. I'll just finish this out real quick. But basically, if the number across from the angle is more than the side next to the angle, then you have one triangle. One triangle. Okay? So there you go. That's the written form. But basically the main rules are to that 1, it has to be side-side angle. 2, the angle has to be acute. 3, if you do a simple trig ratio, then you get that magic number, okay? That magic number. So basically, if it's less than that, you have 0. If it's equal, it's 1. If it's more, it's 2, up to a certain point, because obviously if it's more than the other side, then you have only one triangle, okay? And this is the visual way to look at it. Of course, there's rules in the textbook, and there's a couple formulas usually that they give you to find this stuff out as well. So I hope this visual was helpful for you. This is the ambiguous case kind of spelled out for you in a visual way. So hey, this has been Mr. Kyle at Myers Mathematics. I hope that's been helpful. I have a free guide on my website, myersmathematics.com. I want you to check out. It's the 5 math mistakes everyone makes and how to avoid them. You can download it for free on my website, and I hope it's helpful for you. It's just a simple math guide to put in your pocket so that you can not miss math problems anymore. So I'm going to check that out. And I hope that's been helpful, and hope this video has been helpful. If it has, like and subscribe and all that. Peace.